Hello everyone, and thank you for joining this webinar, held part of the Practitioner Education Series. My name is Phil Locke, Team Leader of Plumbing Technical and Regulation, and I'll be your host for today. Please note that we're running a hybrid webinar that includes live streaming and learning content with interactive polls and Q&As answered by my technical team. I encourage you all to please type your questions into the Q&A chat function during the live streaming, and also to participate in the interactive polls. Today's webinar is about fundamentals and some of the common inquiries we receive for graded drainage systems. So please enjoy. I would like to begin by acknowledging the traditional custodians of the land in which we meet today, and I pay my respects to their elders past and present. I extend that respect to the Aboriginal and Torres Strait Islander peoples attending the session today. Today you'll be hearing from Neville Campbell. Neville is a Senior Technical Advisor within the Technical and Regulation Plumbing team. With over 18 years experience in the plumbing industry, Neville has worked in both commercial and domestic sectors prior to joining the VBA. Neville is an adept technical writer and routinely represents the VBA in matters before the Victorian Civil and Administrative Tribunal. As Victoria's building and plumbing regulator, the VBA is committed to ensuring a confident and thriving industry and collaborates with stakeholders to enhance practitioner capabilities and deliver improved outcomes for the community. Next slide. Now, before we begin, I'd like to let you know that this session is being recorded and the link to the presentation made available on the VBA website, along with other previous webinars. Time permits, we'll be answering some pre-submitted questions during the Q&A session at the end of the webinar. Please still submit your questions via the Q&A chat function during the webinar, as the technical team is available to answer your questions in the chat room. At the end of the webinar, we'll collate all the unanswered questions and we'll provide an answer to as many of these as possible. A copy of the Q&A will be sent with your proof of attendance certificate in the following weeks. Also, during the webinar, we'll be conducting live polls that will automatically appear on your screens. Feel free to use the QR code reference on the slides to direct you to the relevant websites relating to the topic being presented today. We'll do our best to answer as many of your questions as we can during the webinar. However, we receive a large volume of questions and we may not have time to answer the questions during this webinar. So after the webinar, we'll collate all the unanswered questions and provide answers to as many of these as possible. A copy of the questions and answers will be sent with your proof of attendance certificate in the following weeks of the webinar. Neville, I'll hand over to you.
Thanks, Phil, and good afternoon all. The purpose of this webinar is to remind practitioners of the fundamentals of deemed to satisfy drainage design. This webinar will also highlight some common inquiries. By the end of this webinar, you'll have a better understanding of the fundamentals of drainage design for various classes of buildings. This webinar will explore some common deemed to satisfy requirements for the design and installation of conventional sanitary drainage from fixtures to a network utility operator's sewer, a land application system, or a holding tank. We'll also look at some of the common inquiries we receive here in Tech and Reg. This webinar will not address above ground, sanitary stack, or vacuum drainage systems. For the purpose of this webinar, references to drains are references to drains laid in unplasticized polyvinyl chloride, pipe and fittings, unless otherwise stated. The information presented in this webinar is based on Australia New Zealand Standard 3500 Part 2, 2021, the National Construction Code 2022, and current Victorian plumbing law. The webinar will explore sanitary drainage fundamentals such as overflow relief, reflux valves, and disconnector gullies, boundary traps, inspection shafts, and atmospheric venting. and the new requirements for oblique junctions in below-ground drains. The learning goal for this webinar is to reinforce the fundamentals of drainage design for various classes of buildings. Sanitary drainage fundamentals. So what is drainage work? Drainage work is the construction, installation, replacement, repair, alteration, maintenance, relining, testing or commissioning of any part of a below-ground sanitary drainage system, from the above-ground sewage or waste pipes up to the approved point of connection. This could be a network utility operator sewer, a land application system, or a holding tank. It also encompasses below-ground stormwater drainage, but we will not cover that in this webinar. What is not drainage work? The opening and closing of inspection openings, caps, covers in sewage and waste pipes, the clearing of blockages or closed-circuit television of inspection of sewage waste pipes using existing openings and removable grates, design work that is carried out by a building practitioner, an architect, a draftsperson, an engineer, a landscape architect, or a designer. A sanitary drainage system must ensure that sewage is transferred from a sanitary plumbing system to a disposal system, which is approved by the authority having jurisdiction. These will typically include a network utility operator sewer, a land application system, or a holding tank. Where a point of connection to a network utility operator's sewage system is not available, an on-site wastewater management system must be designed, installed, and maintained in accordance with the requirements and agreement of the relevant authority having jurisdiction. Now we'll look at some of the fundamental components of a sanitary drainage system in some common scenarios. The first one is a typical Class 1 dwelling. This is your average home, or it might be a townhouse with its own sewer connection point. In this scenario, each drain must have a vent located at both ends of the drain if the drain incorporates a boundary trap. At the upstream end of the drain, if the drain is in a boundary trap omitted area. At the upstream end of any branch drain that exceeds 10 metres from the vented drain to the rear of the trap. You must have an overflow relief gully. A reflux valve may be used in lieu of an overflow relief gully where the site's entirely built on, or where there are no acceptable alternatives, or the ORG may be omitted where the lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection. Our second one is a site with 2 Class 1 residential buildings. In this scenario, the drain must have a vent located at the upstream end of each building, at the downstream end of the drain if the drain incorporates a boundary trap, at the upstream end of any branch drain that exceeds 10 metres from the vented drain to the rear of the trap, at least 1 overflow relief gully. A reflux valve may be used in lieu of an ORG where the site is entirely built on and there are no acceptable alternative locations, or the ORG may be omitted where the lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection. In this figure, the ORG is located at the downstream end of the shared drain. In practice, it could be located at either dwelling, provided the clearances from the lowest fixtures are achieved for both buildings. We'll discuss venting and overflow requirements in greater detail later in this presentation. Our third example is a site with 3 or more residential buildings, such as 3 villa units. While our example has 3 buildings, it could easily be more than 3. And if the 3 Class 1 dwellings were under the same roof line, they would still be considered 3 individual buildings. In this scenario, each drain must have a vent located at the upstream ends of each building, at the downstream end of the drain if the drain incorporates a boundary trap, at the upstream end of any branch drain that exceeds 10 metres from the vented drain to the rear of the trap. You must have at least 1 overflow relief gully at each building. A reflux valve may be used in lieu of an ORG where the site's entirely built on and there are no acceptable alternative locations. Or the ORG may be omitted where the lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection. and an inspection opening at or near surface level at each building. This example is a typical arrangement of Class 8 commercial industrial buildings, such as factory units. In this scenario, each drain must have a vent located at the upstream end of the drain, at the downstream end of the drain if the drain incorporates a boundary trap, at the upstream end of any branch drain that exceeds 10 metres from the vented drain to the weir of the trap, at least one overflow relief gully. A reflux valve may be used in lieu of an ORG where the site's entirely built on and there are no acceptable alternative locations. Or the ORG may be omitted where the lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection. An inspection opening at each building. Although it is not mandatory, it is recommended that the IO is raised to ground. Note that in this scenario, the drain doesn't require a vent at each factory unit, provided that there are not more than 2 water closet pans connected and that the branches do not exceed 10 metres in length. The last example is a Class 2 building. This is a typical apartment building with one sole occupancy unit located above another. In this scenario, each drain must have provision for ventilation at the upstream ends of each building, at the downstream end of the drain if the drain incorporates a boundary trap, at the upstream end of any branch drain that exceeds 10 metres from the vented drain to the weir of the trap, at least one overflow relief gully. The reflux valve may be used in lieu of an ORG where the site's entirely built on, or there are no acceptable alternative locations. Or the ORG may be omitted where the lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection. In this type of building, if the ground floor is a car park and the lowest fixtures were on the first floor, the ORG could be omitted. Too far? Quiz time. How many overflow relief gullies are required in a multi-unit development of 3 or more residential buildings? Is it 1 per building, 1 for the whole site, or none? The correct answer is A, 1 per building. Remember, this could be 3 Class 1 dwellings under the same roof line. Now we'll look at drain locations and typical sizing parameters. This is typical of some of the common questions we get here in Tech and Reg. So location of drains. If a drain is located under or inside a building, it should only serve fixtures within that building. Where this is not practicable, the plumbing regulations of 2018 make provision for a drain that serves other buildings to be laid under another building, provided the following conditions are met. The drain is laid as a straight line of drain under the building. The drain has inspection shafts terminating at finished surface level, installed in permanently accessible positions in the open air at the upstream entry and downstream exit points of the building. And there are no branches or changes of direction in the drain between the inspection shafts. Quiz time. In the figure below, does the drain under Garage 2 comply with the plumbing regulations of 2018? Is it yes, no, or not sure? The correct answer is no, because connections and offsets are not permitted under the building. Sizing of drains. The minimum size of a main drain must not be less than DN 100. The minimum size of a branch drain must not be less than DN 65. DN 100 drains laid at 1 in 60 should not exceed 165 fixture units. Drains should be sized by the number of fixture units and the type of fixtures discharging into it. Drains should not be upsized for the purpose of reducing grade. Discharge pipes of DN 50 or smaller must not be installed below ground unless they are connected to a floor waste gully or a vertical riser from a graded drain. This is a Victorian requirement under the Plumbing Code of Australia. Which waste pipe configuration is correct? Is it 1, 2, or both 1 and 2? The correct answer is 1, because discharge pipes of DN50 or smaller must not be installed below ground unless they are connected to a floor waste gully or the vertical riser from a graded drain. Again, this is a Victorian requirement under the Plumbing Code of Australia. Sanitary drainage systems must avoid damage from superimposed loads, such as loads from buildings and vehicular traffic. To achieve this, the standard requires drains to be laid with the appropriate depth of cover. Excuse me. The table pictured here collates the requirements for plastic pipes in some common scenarios. As you can see in the table, the table is divided into 4 columns. The first column is the location of the drain. The second is the amount of overlay required, and the third and fourth columns cater for pipes underneath paving or concrete. For example, the first row is for plastic pipes that are subject to vehicular traffic without any concrete or paving. This is indicated by the respective concrete and paving columns being blanked out. The second row is for pipes subject to vehicular traffic. However, this time there is also 100 millimetres of reinforced concrete above the overlay. Note that any concrete or paving must extend the full width of the trench, or the drain must be mechanically protected from damage. This table indicates the minimum separation requirements between a below-ground drain and other services. This table has 6 columns. The first column is the scenario, and the following 5 indicate the minimum clearance that a drain must achieve from another below-ground service. For example, the first row shows that an electrical supply cable for a consumer gas pipe that is indicated by a marking tape and mechanically protected for its full length only requires 100 millimetres of separation. Row 2 shows that if the same electrical cable or gas pipe were not marked and protected, that distance must be increased to 600 millimetres. As with our previous table, columns that are not applicable to certain rows are blanked out. Note that the vertical separation, angle of crossing and marking requirements set out at the bottom row are the same for all services. Reuse of drains where buildings are demolished or removed. Where a building is demolished and replaced, existing drains must also be replaced to the point of connection. However, drains may be reused if mortar-jointed vitrified clay, mortar-jointed concrete, asbestos cement and fibre-reinforced cement have been renovated using structural plastic liners, or drains constructed of other materials have demonstrated compliance with the relevant sections of the standard, for example, grade, bedding and testing. Further guidance can be obtained from Practice Note DR3, Property Sewer Drains. Excuse me. Building over drains. When making alterations or additions to buildings, the footing system should not be placed over or adjacent to existing drains unless appropriate clearances have been achieved. Clearances include the angle of intersection with the footing, the annular space for wall and footing penetrations, installation of flexible joints if required, and the angle of repose from existing footings. Inspection shafts and boundary traps should not be built over. Where this cannot be avoided, the inspection shaft and boundary trap may be located under a roofed area or in a recess, subject to the relevant requirements of the standard. Now we'll look at inspection shafts and boundary traps in a little bit more detail. Inspection shafts and boundary traps general requirements. Each drain must be provided with a boundary trap in a boundary trap area or an inspection shaft in a boundary trap omitted area. Inspection shafts and boundary traps must be located in an accessible position in the open air, finished with an appropriate cover, that would be a light or heavy cover depending on the situation, wholly within the property that it serves, and as near as practicable to the property boundary and the point of connection to the reticulated sewer, and clear of easements unless approved by the owner of the easement. Provisions for alternative locations may also apply. Where the inspection shaft or boundary trap cannot be sited in an accessible position in the open air, an alternative position may be used as follows. The riser may be installed under cover, such as under a roofed area, provided the cap is finished at surface level and is readily accessible with not less than 1 metre clear space above the cap, and the cap is airtight. Alternative location 2. The inspection cap may be recessed into an external wall of a building if the building is constructed up to the boundary and it is impracticable to site the inspection cap in the open air or under cover. The inspection cap is airtight with 100 millimetres clear space around the cap. There must also be 1 metre of clear space above the cap, and the recess must have a removable panel. Alternative location 3 is inside a building. A boundary trap or inspection shaft may be installed below ground inside a building, provided the room is not a habitable room as defined by the National Construction Code of 2022. Examples of an acceptable location could be a bathroom, a laundry, toilet, pantry, walk-in robe or hallway, or a garage. A boundary trap could also be installed above ground inside a building, for example, in a basement. Where the drain serves more than one building or dwelling, the IS or BT must be in a readily accessible area. Ideally, this would be a common area. The location chosen should not prevent access to the BT or IS, even if the neighbours were on an extended holiday or the house had been sold to someone else. When installed inside a building, the shaft must be sealed with an airtight cap and 1 metre of clear space provided above the cap. Boundary trap downstream ventilation. As we touched on earlier, drains incorporating a boundary trap must have an appropriately sized downstream vent connected within 10 metres of the boundary trap riser. No fixtures or other connections are permitted between the BT and the junction to which the vent connects. Downstream ventilation can be provided by a ground vent directly on top of the BT. This could also be used as an ORG, and we'll look at this a bit closer in a later slide. A junction connected to a BT riser and leading off to an atmospheric or ground vent. A junction connected to a drain within 10 metres of the BT riser and leading off to an atmospheric or ground vent. The connection of a riser that incorporates a stack vent is also acceptable. When must a drain have an appropriately sized downstream vent? Is it when the drain is in a BT emitted area, when the drain has an IS, when the drain incorporates a BT, or all of the above? Correct answer is when the drain incorporates a BT. Upstream vent connections. An upstream vent on any drain must be connected to the drain downstream of a fixture or drainage trap connection, or at the vent extension of a stack or waste pipe located near the upstream end of the drain, and so that the unvented drain upstream of the vent connection does not exceed 10 metres in length. All drainage systems must have an upstream vent open to atmosphere sized for the entire system. Atmospheric ventilation may be provided by an appropriately sized single vent or by several vents which provide the same or greater cross-sectional area. For example, if the sizing required a 65 millimetre vent, you could use 2 50 millimetre vents instead. Under no circumstances should vents be smaller than the following minimums. Upstream vents should not be smaller than DN 50 mil. A below ground a ground vent shall not be smaller than DN50, but just be aware that 50 mil ground vents cannot act as an ORG. Branch vents should not be smaller than DN40, but they may be replaced by an AAV. In this figure, there are no fixtures depicted. We're only showing ventilation requirements here. Air admittance valves or AAVs. AAVs may be used to ventilate a branch drain, provided the system has at least one upstream vent on the main drain, which is open to atmosphere. AAVs must not be used for upstream venting of a main drain, venting of a boundary trap, or to vent an interceptor appliance. Now let's see who was listening to what I just said. Can an air admittance valve be used as an upstream vent on a main drain? Is it yes? Yes if it has a downstream vent, no or not sure. Correct answer is C, no it can't. Boundary traps and overflow relief. A boundary trap may also serve as an overflow relief gully, provided the overflow height is not less than 150 millimetres below the lowest fixture connected to the drain and 75 millimetres above ground level, or if installed in a paved area, finished at a level that will prevent water ingress. Where a low-level vent serves as an overflow ground vent, or OGV, it must terminate 150 millimetres above ground level and 150 millimetres below the lowest fixture. Note that a ground vent must not be closer than 3 metres to an opening into a building. Where a BT also serves as an ORG and is installed within a building or alternative location, the BT must comply with the same provisions as a regular ORG in an alternate location. We'll look at this in greater detail in a later slide. Too far. Boundary trap and inspection shaft termination. BTs and ISs that are installed in the open air must terminate as follows. Where an inspection shaft or boundary trap riser is located clear of a building, does not terminate to a ground vent, and is not likely to be damaged by vehicular traffic, a light cover must be installed. This is a Victorian requirement under the Plumbing Code of Australia. Where a shaft is subject to vehicular traffic, a heavy-duty trafficable cover must be installed at finished surface level. In either case, the shaft must be fitted with an airtight cap immediately below the cover. The cover must be supported independent of the shaft so that no load is applied to the shaft, and risers must be installed vertically with no offsets. Now we'll take a look at gullies. Essentially, either configuration in this picture could be a DT or an ORG, depending on its intended purpose. The disconnector gully is installed internal or external to a building to provide disconnection between the waste discharges and the sanitary drainage system. An overflow relief gully is installed internal or external to the building as provision for relief from sewer surcharge from the reticulated sewer. Note that gullies must have risers installed vertically with no offsets. Again, this is a Victorian requirement under the Plumbing Code of Australia. A floor waste gully is considered a fixture trap and must be installed inside a building and finished at surface level with an accessible, removable grate. ORG locations. The ORG must be located within the property served, external to the building, where the discharge is noticeable with more than 2 metres clear space above the grate. Note that risers from gullies must extend vertically from the water seal without being offset. Height of the overflow. At least one overflow relief gully must be installed in each drain. Additional gullies are recommended where lower buildings may be affected by surcharge from higher buildings. It may be omitted if other relevant provisions have been met. The ORG overflow height must be minimum 150 millimetres below the lowest fixture connecting to the drain. In a typical Class 1 dwelling, the separation height is measured between the spill level and of the ORG and the following. For a water closet pan, it's the top of the water seal. For a floor waste gully or shower, it's the surface level of the grate. And for other fixtures, surface level of the outlet. The spill level of the ORG must be 75 millimetres above ground level, or if installed in a paved area, finished at a level that will prevent water ingress. ORG alternate location 1. Where it's not possible to locate the ORG outside the building, the standard provides for the ORG to be located inside the building, provided the gully riser is raised to floor level and sealed with a removable airtight cover. The riser has an equally sized overflow pipe connected above the water seal. The overflow pipe discharges to the open air at an outside wall. The overflow pipe must be graded at not less than 1 in 80 towards the riser, and no fixture connections are permitted to the overflow pipe. The second option is to locate the ORG in a recess on the outside of the building, provided the recess is not smaller than 300 millimetres wide and 600 millimetres high. The base of the recess is graded away from the building. The riser is not more than 300 millimetres from the face of the building and is fully accessible. Omission of an overflow relief gully. An overflow relief gully may be omitted in the following situations: where the site is entirely built on and it is not possible to locate the gully in an acceptable location, and the ground floor fixtures discharge through a reflux valve. The lowest fixture connected to the drain is at least 3 metres above the ground at the point of connection, or the drain serves toilets or amenities in a park or reserve, the floor of which is graded towards an external door. So one place you might see the 3 metre rule applied is in a Class 2 building with no fixtures on the ground floor, or it could be a house on stilts or a steep block. When must reflux valves be installed? When the spill level of the ORG is less than 150 millimetres below the lowest fixture. So if you can't achieve this overflow height, this here, it must be installed. Where a basement fixture could be affected by surcharge from a fixture at a higher level. An example of lower fixtures might be a laundry in a basement being protected on that specific branch of the drain. A reflux valve may also be installed where drainage from below ground grey water diversion devices gravitates to the sewer. Note that in known surcharge areas, the Water Authority's conditions of consent may require a reflux valve to be installed. Quiz time. When must a reflux valve be installed? Is it when the spill level of the ORG is less than 150 millimetres below the lowest fixture? Is it where the basement fixture could be affected by surcharge from a fixture at a higher level? Is it where drainage from below ground grey water diversion devices gravitates to the sewer? Is it in known surcharge areas? Or is it all of the above? The correct answer, of course, is all of the above. Where must a reflux valve be installed? Where a reflux valve is installed as protection against sewer surcharge, it must be located immediately downstream of a boundary trap or adjacent to an inspection shaft in a boundary trap emitted area. Reflux valves must be maintainable from their installed position. This could be installed above ground, installed in a reflux chamber, or able to be maintained from finished surface level. Inspection opening requirements. So outside of a building, inspection openings must be positioned within 2.5 metres of the building on each branch connecting a water closet, at intervals of not more than 30 metres at the point of connection, at or immediately upstream of a jump-up lead-off connection, or where a new section of drain connects to an existing drain. At least one inspection opening must be raised to or just below ground level on each main drain. This could be an inspection chamber, an inspection shaft, a jump-up riser, a boundary trap riser, or a reflux valve riser. It is not recommended that a reflux valve riser is used for maintenance, as this can damage the valve seat. Junctions in drains. Junctions installed in the vertical plane can be used to connect drains at different elevations, a single discharge pipe, or a jump up. The following restrictions apply to junctions installed in the vertical plane. The riser must not exceed 2 metres from the graded drain invert. Junctions in the vertical plane must not be used to connect a stack below ground. The junction must be supported on concrete riser if the junction must be supported on concrete if the riser extends 1 metre or more or is raised to ground. The 2 metre rule applies from the invert to invert, but does not apply to the riser extension between the lead-off and ground level. So this jump-up requirement, if I can get my laser pointer to work, applies from invert to invert. If this were extended to ground level, that doesn't come into the 2 metres. Construction of a jump-up. A jump-up can be constructed with a bend or a junction at the base. Sweep, square, and 45 junctions can be used to connect the riser into the shaft. A jump-up should be used to connect drains at different elevations or where the full depth of the authority's point is not required. Note that jump-ups within 3 metres of the point of connection must be raised to ground level. Jump-ups with an inspection shaft extended to ground are known as an inspection shaft jump-up, or ISJU. Inspection shafts, or ISs, are constructed with a square junction at the base, and no connections are permitted in the IS riser shaft. Note the difference here between the jump-ups and the inspection shaft. It's all about this connection here. This is a square junction, so there can be no connections in this riser. Connection of a stack to a below-ground drain. Stacks connecting to below-ground drains must connect by 2 45-degree bends separated by a straight length of pipe, which is not shorter than twice the diameter of the pipe, or an 88-degree bend if the stack extends through not more than 2 floors. Where the stack connects through a junction, the junction must be a 45-degree junction on grade and an 88-degree bend if the stack extends through not more than 2 floors, or 2 45-degree bends separated by a straight length of pipe, which is not shorter than twice the diameter of the pipe. So, for example, if you're using 100mm DWV, the straight section of pipe between the 2 45 bends, which is this bit here, should not be less than 200mm in length, so as to form a long radius bend. Note that where the stack and the main drain are unequal sizes, the change in size must be made above ground using a taper fitting. So if your main drain was 150mm and your branch was, or your stack was 100, you would need to make this would have to be an equal junction, 150mm on all sockets, 150mm bend, and then the change in size made above ground using an LIT. Junctions on grade. Where a graded drain is connected to any other graded drain, the connection must be made using a junction with an upstream angle of not greater than 45 degrees. 88 and square junctions are not permitted for this purpose. New requirements for drains, for junctions in drains. On the 26th of September 2023, changes to the plumbing regulations of 2018 adopted the 2021 version of the Australian New Zealand Standard 3500 series as part of the deemed to satisfy requirements for compliance with the Plumbing Code of Australia. For below ground drains, the most significant change is where a 100mm junction connects a 100mm branch pipe to another 100mm pipe, the entry level of the branch pipe must be rotated to 15 degrees above the horizontal. This requirement applies to all drains in all classes of buildings. Note that the drain can revert to grade upstream of the junction. The new requirement is intended to reduce stranding of solids in conjunction with the increase in water efficiency. Unequal junctions. Where an unequal junction is used to connect a branch drain to another drain, the invert of the branch drain must be at least 10mm higher than the soffit of the drain to which it connects. Unequal junctions must not be used to connect a stack. So as previously mentioned, where the stack riser has a smaller DN than the below ground drain, an equal junction must be used with the transition in size made above ground using a taper fitting. Now let's see who's listening. A stack can be connected to a below ground drain by an unequal junction. True or false? True if the junction is rolled up to 15 degrees. True if the soffit is 10mm higher than the soffit of the drain to which it connects. Or false, an unequal junction cannot connect a stack to a below ground drain. The correct answer is C, false. An unequal junction cannot connect a stack to a below ground drain. (88-degree) and square junctions in below ground drains. 88-degree junctions must only be used for the connection of a graded drain into a jump up or boundary trap riser, or as an inlet riser to a gully or a floor waste gully. Square junctions must only be used to connect an inspection shaft into a graded drain, as an inspection opening, as an inlet riser to a gully or floor waste gully, or at the connection of a graded drain into a jump up or boundary trap riser. Note that no connections are permitted in an IS shaft riser. Drains in other than stable ground. The sanitary drainage installation must avoid damage from superimposed loads and ground movement. This is a requirement of the Plumbing Code of Australia. Clause 5.6 of Australian New Zealand Standard 3500 Part 2 also requires the methods of support and bedding of a drain to be designed to suit the ground conditions. For information on ways of demonstrating compliance with these requirements, refer to Appendix A of the standard or our practice note DR04, which is available from the VBA website. Bedding of drains, trench base, side support and overlay. In stable soils, drains may be laid on the undisturbed base of the trench, provided the trench is free from rocks, tree roots and other sharp objects, or laid on an appropriate bedding material. For soils containing clay, rock, shale, gravel or hard objects, the drain must be laid on an appropriate bedding material. Materials used for bedding or filling must be one of the following: crushed rock, gravel screenings, or similar recycled materials sized between 7 and 10mm. Quarter minus is acceptable provided it is consistent in size upon visual inspection. Free-running sand excavated from the trench, capable of passing through a 2mm sieve, which does not contain clay Organic or other deleterious materials is also acceptable. This is a VIC requirement under the Plumbing Code of Australia. So just to reiterate that, it must be excavated from the trench. It can't be brought in. Cement mortar bedding is also acceptable. For more information on bedding of drains, refer to Practice Note DR02, Bedding Materials for Below Ground Sanitary Drains. All new, reused, repaired or replaced sanitary drainage installations must be tested to ensure that they're watertight. Drains may be tested using any of the following methods: an air test, a vacuum test, or a water test using non-drinking water provided by the network utility operator. That means there must be a network utility operator's recycled water on site if you're going down the avenue of a water test. And that is a Victorian requirement under the Plumbing Code of Australia. Concrete supportive drains. So concrete supportive drains must be installed at all vertical rises greater than DN65. So that's all vertical rises, not just mains, also on branches. That's a Victorian requirement under the Plumbing Code of Australia. It must be provided under the junction of any riser that extends to ground level. It must be provided under the junction of any jump up if it exceeds 1 metre in height. Under junctions in drains that form an IS up to the centre line of the fitting. And under junctions in drains that form a jump up continued up vertically to the underside of the bend that is fitted into the junction. Note that is considerably more concrete than the centre line of the fitting. Centre line of the fitting, if it's an inspection shaft or a reflux shaft riser. But if it's a jump up to the base of the fitting, which goes into the junction. Concrete support must be provided under the base of a boundary trap riser up to the inlet socket of the trap. Must be provided under the base of a gully trap and up to the inlet socket of the trap. And it shouldn't be closer than 20 millimetres to a flexible joint. Concrete anchor blocks must also be used to support drains between 1 in 5 and vertical. This applies to all drains up to DN 150 and exceeding 3 metres in length. All concrete must have minimum characteristic compression strength of 20 MPa. Water used for mixing concrete must not be harmful to the mixture, to the reinforcing or anything embedded in the concrete. Note that some rapid set concretes do not achieve 20 MPa. Today, we've looked at the most common drainage questions: boundary traps, inspection shafts, overflow relief, and ventilation for various types of sites.
Thanks, Neville. There's lots of great info there, and I see lots of questions in the chat. Just another reminder that if you haven't answered all your questions, the team is still working through those, and you'll receive your answer in the next few weeks, along with a copy of the questions and answers from the session. Might just move on to some pre-submitted questions we received during the registration process. These were a few of the most common ones. I'll just go to question 1, and it's available there. What are the new 15-degree requirements for junctions in drains, and are they being enforced? Yeah.
Yep, Phil, as we touched on in the webinar, where a 100mm junction connects a 100mm branch pipe to another 100mm pipe, the entry level of the branch pipe must be rotated to 15 degrees above the horizontal. These requirements apply to drains in all classes of buildings, and they will be enforced by the audit and inspection team in the new year.
Thanks, Dev. And another one here we had, where do I have to install swivel joints?
Yeah, I think this was a pretty common theme. The standard requires drains laid in filled, unstable or water charged ground to be designed to withstand the ground conditions. While there's no specific requirements for this, both Appendix G of Australia and New Zealand Standard 3500 Part 2, 2021, and our own practice note DR04, drains in reactive soil, provide guidance on what may be deemed acceptable. For Class P sites, engineering advice should be sought.
Got one more here. What is the plumber's responsibility for does not fall under the building permit approval process? Another one we often get.
A licensed plumber is responsible for all regulated plumbing work that they carry out or supervise. These requirements apply even when there is no building permit in place.
Another one. What are the common errors found in drainage designs?
This is quite a long list, but some of the most common issues are inconsistently sized bedding material, insufficient concrete support, insufficient grade, insufficient separation between services, incorrect testing procedures, and a lack of knowledge around the testing requirements.
That's it. Thanks, Nev. Great presentation, and thanks everyone for joining today. Hope everyone's enjoyed the session. Just a reminder, we'll collate all the unanswered questions and we'll have them to you in the coming weeks. We'll soon be sending out an email, includes a webinar survey and your proof of attendance as well. That'll include a link to the slideshow. Find out more about the next Practitioner Education Series webinars, when they'll be held. Just please visit our website in the coming days and keep an eye out for our email. Thank you very much.